Welcome to Eazy Algebra. Today we want to look at rational expressions and rational equations. So let's start with what a rational expression or a rational equation is. A rational expression is an expression of the form p of x all over q of x, where p of x and q of x are polynomials. So what we end up having is a polynomial over a polynomial. So, if we think back to our knowledge of polynomials, when you multiply two polynomials, you get a polynomial. When you add two polynomials, you get a polynomial. But when you divide two polynomials, you do not always get a polynomial. And that's what we're looking at here. We have something where we have a rational expression, something that doesn't come out to a polynomial when you divide two polynomials. To make this into a rational equation, we simply take our rational expression and we set it equal to 0, or we could have it set equal to a constant. That would be a rational equation. And that's all we're looking for, is how to solve equations that are a polynomial over a polynomial. So let's start with simplifying an expression. So here we have the rational expression x squared minus 9 all over x squared minus 6x plus 9. To simplify this, we need to factor the numerator and factor the denominator. The numerator is the difference of squares. We would factor to x minus 3, x plus 3. Meanwhile, the denominator, we'll have to do a little bit more thought here. We need something that would multiply to give us 9 and add to give us negative 6. And that's going to require it to be negative and negative, so we'll have negative 3 and negative 3. Those will multiply to give us 9, positive, and add to give us negative 6. So this denominator would factor to x minus 3 times x minus 3. And we could have written that as x minus 3 squared, but because we're going to look to cancel, I want to leave this in this form. These would cancel out here, and we would get x plus 3 over x minus 3. The last thing we need to check is, will the domain or range be impacted? So here, the domain, originally we could not put in positive 3. And in our final, we still can't put in positive 3 because that would give us division by 0. X minus 3 could not be 0, so x cannot be 3. And that was true both in the original and the final. Because these were the same here, the canceling did not remove any stipulations from our domain. Had those been different values, like x minus 2 and x minus 3, when we canceled, there would have been a stipulation on the domain that we would have needed to carry over as a comment. So that's how we simplify a rational expression. We factor and we cancel. To solve an equation, there's a little more to it. All right, so we want to look at solving a rational equation. To check for extraneous solutions means to double check the answer that we receive and ensure that it is a working answer. It is possible with rational equations to get an apparent answer that does not work in the original equation. So here we're going to start by cross-multiplying. So we'll do 3 times x minus 1 is equal to 4 times x plus 2. That will give me 3x minus 3 is equal to 4x plus 8. Move the x's to one side. and we get negative x minus 3 is equal to 8. Add 3 to both sides. These cancel out. We get negative x is equal to positive 11. The last step is get rid of that negative by dividing by negative 1. So x is equal to negative 11. But now we need to check that in our original equation. So we need to plug that back into the original equation to see, is that a real solution or is that an extraneous solution? So we plug that back in. Negative 11 plus 2 would be equal to 4 over negative 11 minus 1. So is it true that 3 over negative 9 is equal to 4 over negative 12? And we simplify. This would simplify to negative 1/3. Divide these by 4, and you'd have negative 1/3 again. So negative 11 is a solution to this equation. So that's how we would solve a simple rational equation. We'd use the exact same process if these were polynomials of higher order. But when we got to this step here, instead of having a linear equation, we'd end up with a quadratic equation, which would mean we'd have two solutions. We would check both solutions to ensure they were accurate solutions. If one of them gave us a false statement, that would be an extraneous solution that we would throw out.